Well, good afternoon, and thank you all for joining. My name is Daniel Kok. I'm a professor and head of School of Engineering at Newcastle University, and I'm also the principal investigator of the EPSRC-funded Automatic Control Engineering Network, the ACE network. I'm delighted to welcome our keynote speaker, Carl-Henrik Johansson, and colleagues joining us for the panel discussion later. Now, today we're launching a position paper from the automatic control engineering community. The paper's central argument is simple. The rapid progress in artificial intelligence, particularly with large language models, has been transformative. But what follows is an even more significant transition as AI moves from into the physical world. And while we have national strategies in place for AI, quantum technologies, and engineering biology, we have overlooked a core engineering capability that is critical to making this system safe, reliable, and deployable at scale. I'll start with a short introduction to set the context. We'll then hear from Carl, and after that, I'll come back to walk through the position paper and we'll also open discussion. Now, clearly, AI, artificial intelligence, is entering a new phase from systems that operate mainly in the digital domain to systems that act in the physical world, in energy networks, hospitals, transport systems, and defense platforms. And these are not purely digital systems, they are physical, interconnected, safety critical. So that changes the engineering problem. Recent progress in AI has been dominated by models that generate, that interpret, and predict from data. But prediction alone doesn't determine what the physical system actually does. It's not enough for an AI model to recognize a pedestrian. The vehicle must stop safely and in time. And it's not enough to predict the fault. The system must remain stable while that fault is handled. So the key question becomes, how do we turn sensing in computation into a reliable physical action? That is where automatic control engineering comes in. And on this slide, the key phrase is physical action and reliable physical action. Control is what turns sensing and computation into physical action, provides the stability, safety, assurance needed for the overall system to be certifiable. And it's already embedded in systems we depend on every day, whether it's in jet engines, power grids, surgical robots, or autonomous system vehicles. So when we talk about trusted autonomy, this is engineering layer that makes it work reliably in the real world. And this is not only a technical issue, it's also a major economic opportunity. The UK government's smart machines strategy identifies around 150 billion gross value added at stake from intelligent autonomous systems by 2035. Now, globally, and this is highlighted in the paper, this is already becoming a major investment race in this area. Examples in the paper alone exceed $30 billion in recent private investment across physical AI, robotics, and autonomous systems. But the UK also faces a system productivity challenge and a significant gap in automation investment compared with countries such as Germany. And there is strong evidence that automation is the key productivity multiplier. The question is whether the UK has the engineering capability to realize this opportunity, to scale from today's automation to the AI autonomous systems that are safe, stable, certifiable in real-world operation. The good news is that we are not starting from zero. Over the past 3 years, the ACE network has brought together over 500 researchers, industry partners across more than 20 universities, and our activities focused on energy, manufacturing, health, transport, and autonomous systems. So the role of the network has been to build a foundation for the national capability, community coordination, and a shared direction. That has included sandpit workshops, roadmap development, and establishment of a virtual center of excellence. The governance foundation for the physical center the paper calls for. That work has produced one major output, this position paper we're launching today, and the second is underway, a 2025-2035 research and innovation roadmap that is planned for publication later this year. And together, these outputs set out the path from a strong but distributed research base towards a coordinated national capability. To explore further, I'm delighted to introduce our keynote speaker. Carl-Henrik's work spans network control systems, cyber-physical systems, and autonomous transport, and he has been deeply engaged in questions of national and international strategy for the disciplines for many years. He brings something particularly valuable today, an independent perspective of what countries that are getting this right are actually doing, and what the opportunity looks like from the outside. Carl-Henrik, over to you.
Thank you, Daniel. Many thanks. Thanks for that kind introduction, and thanks for the invitation. It's really my pleasure to get this opportunity to talk about such an important topic as strategic initiatives for automatic control engineering in the area of AI and data-driven industry and society. And as you hinted at, I've been quite deeply involved in the strategy in Sweden, but also in some other countries in Europe and elsewhere. I mean, as was pointed out here, we all depend on complex interconnected infrastructure systems in our daily life, right? The power grid keeps our citizen industry running, the aircraft that carry millions of people safely across the globe, medical devices that monitor and sustain human lives. So we know these systems really form the backbone of our modern society. And we also know that these systems are no longer isolated. I mean, they are increasingly autonomous, deeply interconnected, and constantly adapting to changing environment. And as this complexity now is growing, our demands on the system also are increasing. So we would like to rely on them, despite that we know there is a lot of uncertainty happening and even adversarial actions take place as we are speaking. So we really require this system to be trustworthy and safe. And we know also that failures can be quite severe. And what is important here now, I think, and many with me, is that these requirements, as we see, as the systems now become AI integrated, so these requirements cannot be met by AI and machine learning alone. So machine learning and AI brings fantastic and powerful capabilities that we all use in our everyday life. We have the LLMs, we have the VLMs, VLAs, deep learning, diffusion models, generative AI, and you name it, right? But what we also have learned is that these machine learning models are inherent in that they cannot make guarantees. They hallucinate and have other issues. And when we now talk about integrating them in our physical environment, what becomes even more important that they cannot provide guarantee of stability, safety, or robustness. And that's exactly where control engineering plays a critical role. So control is the engineering discipline that provides the principle, methods, and guarantees that ensure such complex AI-driven system behaves as we predict, that they are reliable and safe, and also that they do that no matter how complicated or uncertain our environment becomes. So I think that we are right now at actually an AI phase shift. So we have seen the fantastic development over the last just few years, but we see also a growing focus on physical AI, embedded AI, embodied AI, or whatever you want to call it, right? So in general, AI-enabled, interconnected cyber-physical systems. And we know now, we start to learn that this will not be an incremental shift. This is something major that is happening and that now requires real-time accountable decision making. And control engineering is something that could provide this layer. And I think that this is a very important argument for this audience that we have here today to understand. So it's not about doing less AI or machine learning, but it's doing, in addition, something about how we integrate AI and machine learning into engineering design methods, as well as into commercial systems and services. And this requires solid systems and control systems thinking approach. So the areas of safe AI, physical AI, resilient AI are rapidly growing, but they require a change of thinking. And as we see internationally, this is actually happening as we speak, and some countries are moving faster than others in this area. What we can see is that many nations are investing heavily in this type of AI infrastructure, but also to understand the challenges and speed up the development, also investing in national test beds, in structured research to industry pathway, positioning themselves to deploy intelligent systems and innovation at scales. So I come from a small country. In Sweden, we have about 10 million people, but we still have some major initiatives actually ongoing. I would just like to reflect a little bit about them. So we have one which is called the Wallenberg AI and Autonomous Systems and Software Program, which is targeting exactly what we are speaking now. So this program has as a goal to educate 600 PhD students for Swedish industry in this area. Right now, we graduate about one PhD per week. That is now, so to say, coming out from the universities in Sweden, going directly into major industry. And industry is heavily involved in this program. So the company that you very well know of, Ericsson, Saab, Volvo, ABB, AstraZeneca, and so on, are not only employing these PhDs, but they're also providing data and experimental facility, which is so important in order to test out new ideas for these students that are working on this. So this could be data sets from AstraZeneca on drug development, or control system with ABB, with robotics, or so on. Another thing that we are doing as we speak now is we are running something in Stockholm called Digital Futures, where we engage about 300 research groups across a few universities and institutions in Stockholm. So KTH, of course, where I come from myself, but also Stockholm University and others. And here we are currently actually turning Stockholm into a living lab. We are developing something we call the Stockholm Digital Sandbox, actually placing now test beds in the city and gathering data, city-scale data, that we now can train AI model, testing new control systems across all the different departments that you would have in a city. So we are talking about health, we're talking about transport, water infrastructure, security, and so on. All this with very strong support directly from the mayor of Stockholm and also with this industry that you could imagine that have an interest in this. So in Sweden we don't have that much money as in UK, but just to give you a scale, so this investment I'm talking about is on the level of hundreds of millions of British pounds on each one of them. So it's quite some significant, and we see that it's making a change now, both for established companies in Sweden, but also moving into new companies and startups and so on. So UK has a world-class research in control engineering with strong traditional engagement from industry. And I must say, throughout my career, I have always looked at UK as the leading control nation in the world. Some of the pioneers of the field are or came from UK originally. And I very much enjoy seeing that this ACE network has come into play and that it's taking this responsibility now to bring together a national action in this area, which I believe is very, very important. So if I may speculate a little bit, I see three priorities which is important now going forward. I think investment is important here in some sort of a natural infrastructure and natural activity needs to take place. One need also to connect the deployment and the research here with innovation so that we have the full sequence in place, and also commit to some mission-driven investment, going beyond what we in academia maybe are used to, the project-by-project cycles, and actually come together across disciplines and in better and stronger effort. And this is exactly what I can see happening in several other European countries right now, and I think we need that in Europe in order to compete in US and China. And I think that it's not only competing or catching up with US and China, because I think if we are talking about these systems and the systems industry that we see in UK and European countries, I mean, this is exactly the next way we are talking about. It's bringing AI into this systems industry that could make a change and could actually be an important contribution of this safe physical AI. And I think UK really has the expertise here, and I think it's the moment to take actions. So thank you very much, Daniel.
Thank you very much, Kalle. I believe that sets the scene very clearly. And I'm really glad you mentioned the strengths of and historical strengths of UK in control. I mean, it's very clear that we have and we always had world-class research in automatic control. And as you highlighted, I think the challenge is on, and the question is whether we do have the infrastructure, the coordination, the strategic investment to turn that into national capability that is required given the opportunity. So it's what's coming next. It's so transformative, and the scale of the opportunity is so huge that probably what we already have in place, it's not sufficient to capitalize on that opportunity. And this is what the paper sets out. It sets out where the capability is most strategically important, and what national actions are needed to close this gap. So the paper identifies 5 mission areas where this capability is critical. Now, we have to recognize these are not new priorities. They're already visible in the government's own strategy documents, from the industrial strategy, defense, smart machines. What is missing is that clear engineering direction for how these priorities will be delivered. And really is the control capability that will have to be developed to translate that intelligence into a safe, reliable physical action. In each of these domains, there is a point where intelligence has to become physical action, and that has to be safe, reliable, operating under uncertainty, and very much important is in real time. And the engineering layer that provides all that is automatic control engineering. And of course, control engineering is not the whole answer, but without it, these national priorities cannot translate into desired outcome. The paper also sets out 3 coordinated national actions. And firstly, sustaining the national coordination through the ACE Network Plus, essentially maintaining the momentum, partnerships, and roadmap activity already built through the current network. Second, we're arguing there is a need for a UK Centre of Excellence, and that is to provide that shared infrastructure, test beds, verification capability, but more importantly, the technical leadership needed for safe deployment. And third, creating a national program to support the long-term mission-driven capability, demonstration, and investment. Importantly, this is not control engineering in isolation. It's about embedding control engineering within the multidisciplinary systems the UK needs across energy, defense, health, mobility, and infrastructure. And together, these actions will move from coordination to capability, and then essentially delivering at the national scale. I'll stop there and open up for discussion. And I'm delighted to introduce our panel. Antonis Christodoulo is a professor of control engineering at the University of Oxford, and he will chair our discussion. Francesca Böhm from University College London, whose research focuses on safety, security, and fault-tolerant control, direct applications to power networks and critical infrastructure. Keith Jackson is chairman of ILICA, but he's been former chief technology officer at Rolls-Royce and Meggitt. He's the founder of companies bringing decades of experience taking control engineering from research into industrial reality. And of course, Kalle has already set the international context so clearly. Antonis, I think I'll hand it over to you for the next page.
Thanks a lot, Daniel, and thanks a lot again, everyone, for joining us for the launch of the position paper today. So my first question is addressed to Kalle. Why do you think control engineering will matter even more in the future? And what are the risks if the UK doesn't invest now?
Yeah, so it's two part to that question, right? So I think that this fact that we talked about now, that actually control is not just about feedback or about controlling things, but it's actually about providing architectures that gives us safety, resilience, robustness, and those components that we know works in control are in the core. But I think that outside our engineering discipline, this is often not so recognized that this is part of our discipline. So I think what is important for control engineering is that we need to be better in communicating that outside our area. And I think in these times when we now talk about AI and ML and so on, we see this start to happen. We see that actually the thinking from control engineering starts playing a role. So this is one part of it. The other thing is, of course, that our discipline traditionally works on many applications. We are not focusing on one applications. And when we talk about the transition now of integrating more AI in this system, one need to have a cross-disciplinary thinking, a platform thinking, which is exactly the type of theories that control can support. What are the risks? And the second part, what are the risks in UK? Of course, it depends what perspective you take. But if you look at your industry, as far as I know, I mean, it's very much, as I pointed out, it's a systems industry. We have a lot of strong industry that will, I believe, in the future actually catching up and integrate a lot of this type of new methods into products and services. This is what I see from the industry in Sweden that I collaborate with. And if we don't then have the competence, if you don't educate the talent in this area, it will be difficult for the industry to make this digital transformation that is happening now. So I see it quite existential, actually. Thank you.
Thanks, Kalle. Keith, do you want to add anything to that?
I think that was a very good answer, actually. I think from an industry point of view, it's about generating wealth for UK PLC and protecting wealth for UK PLC. I think clearly, if we look historically, nuclear power stations have been produced, aircraft have been produced, railway systems are produced, medical systems are produced, and we can make safe systems looking at a complete picture and a big picture. But as we go forward in time, it's really important to look at bigger systems to release value to business and to the country. It's also to look at the vivacity and pace of change that we're going to need to put in, maybe as new technologies evolve and as new geopolitical climates arise around us. So I think we've got to be very aware, and it's critically important that as a country that we have the tools and the knowledge and the skills that we can evaluate where risks are. We can decide. We can be ruthless about inspecting where we choose to buy. We understand where we choose to make, and we've got the skills to do that, and we've got the capacity to do that to make the right decisions. So I think it becomes there's a lot of opportunity to generate wealth, to make our industry stronger. There's a lot of opportunity to generate new skills for people, which are going to be high value skills, and we've got to embrace the technology of AI. But we've got to have the guardrails, the methods, and the processes around that so that we can have deep experts in some areas, and then we can have practitioners who can deploy and work out in the field and make it a success for the country.
Thank you. I don't know if Francesca or Daniel want to add anything. Francesca?
Yeah, my colleagues have already mentioned the aspects, of course, of reliability and let's say the aspects of reliability and safety that control can bring, and also the natural interdisciplinarity skills that control engineering allows. And I think it's important to remember that as systems are becoming more and more interconnected, connected to the internet, let's think of all our infrastructures. Kalle was talking about cities and now all the water and energy, health, everything is interconnected. And therefore, it's really important not to separate the aspects of these systems. We cannot just focus on the intelligence. We cannot just focus on communications. We really need to consider the system aspect. So I think that control is really an enabler of all the opportunities that the new technologies are bringing from AI and everything, really to exploit the maximum of it in a safe and reliable, secure way. But also, I would like to remember the aspects of sustainability and efficiency. So how control can put some boundaries, but also make sure that we implement the opportunities in a way that is efficient and does not spoil the environment, but actually takes into account how we can optimize all the aspects at the system level.
Thank you.
I mean, if I may add, Antonis,
yes, Daniel.
I mean, just to reinforce that message that UK has genuine research strength in the area, but it is fragmented across institutions, and one aspect we identify is that it's not clearly present in the national technology policy, it's not mentioned. And the risk is not that the research disappears, it's still happening. I think the risk is that it stays fragmented, while our competitors or other countries are building coordinated national programs around it. And we highlighted the importance of the productivity, automation deficit. So clearly, we have to do something about those. Thank you.
Thank you, Daniel. I think, Francesca, you in your statement, you mentioned a lot artificial intelligence, and obviously in the UK there's heavy investment in this field. Why do you think separate investment in ACE is necessary?
Yeah, as we are making systems AI enabled or AI supported, I think that really we need to balance that or to enforce that, to boost that with the investments in the control ACE sector, control engineering sector, mainly because these systems are becoming more autonomous, and it is therefore fundamental to be able to put some guarantees in terms of how they will behave. AI can, of course, offer amazing opportunities in terms of prediction, of capability of prediction of the future based on data and the huge amount of data that we have available nowadays. But when we apply AI to take action in physical systems, we also need to be sure to guarantee that the action that will happen is safe for the humans, for the systems, for the environment, for our infrastructures, is also secure in the sense that as the systems are also interconnected and connected through communication networks, that there are no vulnerabilities coming also from the cyber layer that could impact the behavior of these systems, and also that this system continue to be resilient and robust. When talking about real-world systems, we need to take into account that there is always some uncertainty. Things do not behave as in our models. We cannot just rely on what was in simulation, what was in the data. Things can change, and therefore it's important and really control is the answer to be able to guarantee this predictability, to be able to allow resilience to this uncertainty, to faults, to changes over time, to adapt in a safe way. So I think that's the main aspect to me. There is also another important aspect just to add, which is related to skills. So we are investing a lot on AI, and of course it's important that our students learn about all these new technologies and how to exploit them for the wealth of our nation, but also we don't need to forget that when we apply AI in real-world systems, we need a set of interdisciplinary skills which are not just limited to, let's call computer science skills or coding skills, but need also to take into account how the other systems work. So, yeah.
Yeah. Thank you. That's a very interesting point. Kale, did you want to add anything to what's been said?
Yeah, I would like to come back to what Keith mentioned about guardrails. I think the guardrails here to understand so to say, the constraints and within what domain and area we allow to work in for a system is extremely important. I mean, in control engineering, we have the concept of a plant, right? A plant can be a vehicle, can be a satellite, can be a body, or anything. And I mean, when we now are applying and trying to develop more data-heavy type of algorithm for this, I think that notion is fundamental. And that means also that in control we are very used to work with other disciplines which are specialized, could be in vehicular engineering or space technology or whatnot, right? And that way of working very close with a specific sector, a specific domain, and integrate now the systems development around that. I think this is the way forward, and I think this is fundamental. And I see some of what is happening which doesn't have any guardrails and developing what is called world models or something in the pure AI community. It can do fantastic. Of course, you can scan San Francisco and get taxis driving pretty impressively, right? But does it scale to the world, right? Does it scale now under all these different circumstances and uncertainty and things that Francesca mentioned? Not, right? So I think there is something actually fundamental in how to develop that, and I'm sure that control needs to be part of that. And then, of course, ACE is the community in UK who should be part of that and drive and be part of driving this in UK.
Yeah. Thanks, Kalle. No, Keith, we want to add something more on the industry perspective.
Just something very quick. I think you've had some very good answers, but I should just update a very old joke about control systems. There are control systems jokes, after all. If someone told me, having worked at Rolls-Royce and Meggitt in aerospace, if I was getting on a plane where all the control systems on the engine were by AI and all of the flight systems were by AI and the air traffic control was by AI and it was all designed by AI, I think I'd make the decision to walk. And that's really, we have to understand they're quite different things. And it's at times you have to have that robustness and rigor where safety comes into it. Sometimes you can be a lot more relaxed. If it's just predicting what the next thing you're going to buy at the grocery store, you can be much more relaxed because the consequence of getting it wrong is not serious. And it is all this about guardrails and using the tools, but it's also about making sure that where it's appropriate, we bring the right skills in. So the question is, with all this investment in AI, do we really need this? I'd say yes, of course we do, because they're quite different things. And if we want to be safe, predictable, and transparent, we need something like ACE.
Thank you. Daniel, any final thoughts on this, or perhaps we should move to the next question, right? Which is has to do with what we're really proposing here. So a network plus, a center of excellence, and a national program. How do these three tools change capability in practice?
Yeah, I think from speaking from an industry point of view, as having been a CTO in industry or having my own company, hugely is the answer. I might sit there and think I want to do something more about bigger systems and control and AI, but I have to convince my board to invest. I have to build confidence. I have to be able to experiment. I have to be able to get to a sandpit to try things, maybe put my data or put parts of my systems into it. I need to have people that are capable that don't exist within my organization. And if I can do all of that and I can demonstrate some early wins or just some early potential, I can then start building, and then I can put some longer term ambitions into my roadmap to generate some vivacity and returns, because success breeds success. I think in the UK, we tend to be long-term investment cautious in many industries. There are exceptions, but I think that's the way we tend to be. And I don't think that's necessarily all bad. But I think when you look at something like this, which could be quite fundamental to the way we approach controlling systems and systems, and going back to the first point on value, I think it's important that we have those tools that helps industry take those steps forward. So I would say, yes, it's very important and quite transformational if we want to see an industrial, whatever industrial means, resurgence within the UK.
Thank you. Daniel.
From the network's perspective, I would say the immediate difference, which is already being felt, is that coordination. So right now, control engineering community operates across over 30 research groups, but no shared infrastructure, and probably coordination was always a challenge. A Network Plus will change that. Will continue the work of the current network. The roadmap that we will come up out of the current network will set ahead the priorities and direct the seed funding to the most important problems. And thirdly, I think connection to deployment. I think translational pathways between the researchers, regulators, industry are currently weak. And I think the Center of Excellence and the national program are designed specifically to close that gap.
Thank you. And Kalle, can you give an international perspective why such a thing is important, those tools, the proposals we're putting forward today?
Yeah, I think there are two things which are important here so it's important with the engagement from both industrial and public stakeholders, but this is important on two different levels. I think this needs to be recognized. One, of course, needs to convince the leaders, those who can maybe make priorities and actually fund and so to say lobbying for this. But in parallel with that type of activity in trying to actually discuss this as a national priority of importance for the country, I think one also need to actually start working on a lower level. We are talking about PhD students and others in real projects with industry, where actually the industry and maybe also in the public sector, they actually start seeing some steps forward here. So that one build a little bit, you can say, a way of communicating then the importance that is supported both from the bottom, so to say, with some success stories, some low-hanging fruits where one can show that this could actually grow into something bigger. But in parallel, then also having this more long-term strategic discussion where it's recognized by those who can actually help setting the priorities, if it's with the funding agency or we are talking about private funding or other public funding here. I think both these needs to be done.
Thank you. And Francesca, any final thoughts on this point?
To me, it's a lot about community building and really trying to build that critical mass that allows to be ambitious and to reach higher achievements, being able to collaborate and yeah, really being able to do better things together. And I think this is related also if we build that critical mass and that nice collaborative environment, I think this will allow to retain and attract the best talent in the sector. That we don't want to lose with respect to what we have had we have now as excellence in the control engineering community. And of course, we'll also make things easier on the translation side on how to being able to exploit the research outcomes, the research findings in innovation results, and therefore this would have a benefit for the society and the industrial sector as well.
you. I think one of the key messages that your panel is sending is that it's difficult to certify autonomous and safety critical systems at scale. Is that true? Can we do that?
Yeah, I mean, the answer is yes and no, because we have, as we've mentioned before, we've got nuclear power stations. That was done many, many years ago and still is done. And they are at scale, maybe a different sort of scale, but they're hugely critical and they are safe, or safe as we can realistically make them. But realistically, no, when systems are new, less constrained, more complicated, evolving, we just won't have the manpower and the tools and the processes and the prior experience and knowledge. You can't take 20 years over some of these things to decide how you're going to do it. You need that pace and vivacity. So I think the answer is yes and no. We clearly, there's a fundamental capability there, but have you got the capability and volume? I don't think so. Without something to help automate and progress. And something I haven't mentioned, I apologize, someone else has mentioned it already, is that through all of this, there's another threat that comes in from the side. There's a commercial threat and an opportunity threat, but there's also the threat of mischief. As you build these bigger systems, they've got to be robust to intrusion. And if you don't really understand everything that's going on inside of it, how do you know if someone's intruded into it and has put something malicious into it? So I think, have we got all of the capability now? No, I don't think we have. Does it mean we can't? No, but it will take time and investment and putting the right brains in the UK and around the world. And I think we have to work with ourselves and we have to work with others and decide, as we talked about right at the start, what capabilities we do, what capabilities we buy, and what capabilities we make sure that we've got robustness in optionality in our knowledge of how we build these safety critical systems and systems with AI.
Thanks, Keith. Can I just pick up on something that you mentioned and perhaps drill a little bit further? So what does this mean for defense and sovereign capability? Can the UK really rely on external technologies for safety verification, safety critical systems in the future?
So is that a question for me?
Yeah.
I think it goes back to that first point. I think it would be a brave, maybe in the United States or China, you can say, I'm going to do this all myself because of the resources and the capability there. But can the UK? No. But I think because of the cost and all of the things we would want to invest upon. But can we be the smart shopper that knows, let's keep using these phrases, what we do and what we buy, but things that we do because we're good at them and they differentiate us and they give us the strength that they need. Things that we buy because we consider them more of a commodity and there's options in terms of how you get this. Things that we don't do today, but we should be growing that capability, and things that we are doing today, which we shouldn't be doing because it's actually become more commoditized. And I think around when you look at building big systems of things, you always have to look at all of the bits, all of the components, and decide what you're going to do. So if you take an example of car companies do this, Rolls-Royce does this, they'll look at their engine and decide which bits they're going to really buy, which bits go into trusted single suppliers, and which bits are commodity. Nuts and bolts will be a commodity. Turbine blades will be something they do themselves. You have to work this out and have a strategy around it. But you've got to have, I think it was Carla was mentioning right from the start, the solution is not universal. The solution will be maybe what you do and what you buy may vary from medtech to defense to aviation or whatever, and power gen. You have to make different decisions and understand that it won't be a universal solution.
Thank you. I don't know if Carla, you want to add anything onto this. I note that we're now getting some questions from the audience. Please type them in. We'll be able to at least do one of those. Or Daniel, to this question of whether the UK can rely on external technologies for autonomous and safety critical systems? No? Okay.
Antonis, I mean, what I would like to add on that is that clearly UK AI safety agenda is a genuine strength. I think the challenge is that AI safety is currently framed is largely about model behavior, bias, alignment, and misuse. So it doesn't really fully address the system level behavior. And one thing we learn as control engineers is that when you close the loop, you're actually modifying the system's behavior, you're changing the dynamics. I think that is still an open question, is how does AI in the loop will interact with the feedback, closing the feedback loop, because that changes causality. So it's something that it's probably that's the big challenge that in terms of certification, but for the future when AI will actually have more freedom to control, interact with the real world.
Thanks, Daniel. So there's a question from the audience that Giuliano, let me read it out. So this is to address to Kalle. So the theme of data, as highlighted in your talk, Kalle, obtained from the urban environment and used to bridge AI and control on one side and the real world on the other. So is there an argument here to support coordination in data gathering, like tools, resources, and expertise, possibly nationally, to in turn connect theory and application?
Yeah, that's an excellent question. It's actually at the core. Why are we doing this at all? It's a mess, right? To go out and try to gather data and share data and so on. But I strongly believe in that to make significant progress, we as a field, as researchers and so on, we need to be more out there, and we need to face also these problems at gathering data, making sure to both secure data, but also, finding outliers and all these practical things. And so far, I can just give you an example. Like, I mean, you can go in on the transport in the road network around Stockholm and follow basically any traffic, and there are cameras online and so on. So the system is there, and it's very public and so on. While we have been working with the water infrastructure people in Stockholm, and they have been very scared about all the leakage, not about leakage of water, but leakage about their data, because they heard about various intruders and cybersecurity and cyber attack. Now we have secured this type of data, and we work on this data. They are not public yet, but we really think that the process of trying to make some of this data public, some maybe still will be private, but actually be exposed to some of these problems which traditionally control engineering was not exposed to, because we controlled an industrial process and no data was going to leave that building. So I think it's not only getting the data and being able to do research or control around the data, but it's actually the process of being able to use and provide that data, which I think we need to learn better in our community. And hopefully this can then benefit when we go beyond, so to say, individual test beds and so at scale.
Okay, Kalle. I think there is one more question in the chat, which I will paraphrase a little bit and address Francesca for a very quick answer. So how do we design control systems with AI components that remain safe as AI evolves? And AI evolves really quickly. So how do we keep pace?
Well, I don't think that there is just one answer to that, of course, but how I envision it is anyway in a modularity way. So not necessarily we need to modify the entire architecture every time that a component changes. And this should hold also for the AI component. Of course, we have sensors that evolve, we have controllers that evolve, computers evolve, everything evolves. I think this is a problem of really system design, architecture design, and for I think it's a bit about using control engineering to design the entire system, taking into account that AI is a component nowadays and probably inevitable. And for taking into account on how the various parts will interact and how we make that interaction safe and that can evolve and adapt over time in a way that does not need a redesign of all the time. There was some aspects of plug and play. I mean, of course, the answer could be much longer, but that's a bit the vision.
Yeah, that's great. Well, I'd like to thank our panel today for the very deep discussion on this very important topic, and I'd like to give back the Daniel is going to continue discussing what next.
Thank you, Antonis. And just to add my thanks to our panel, I think it was a rich and important discussion. I just want to close with three things we are asking everyone in this room. First of all, engage, please. Help shape the ACE Network Plus proposal, obviously the Center of Excellence and the national program. We want to hear from you. Talk to us directly. Secondly, back the case for national investment in ACE. Share the paper with colleagues, institutions, funders, policymakers. And then don't forget to connect, join the community at ukcontrol.org and engage with our activities, take part. Three dates to note before you go. So the Network Plus proposal, we're planning to submit around July. Consultation about this direction will be open, and your input will shape it directly. The Research and Innovation Roadmap 2025-2035. It's still under development through October, and we are planning to publish that later this year. And finally, the UCA Control 2026 flagship conference takes place in Newcastle from 23rd to 25th of June, and details are at Control 2026. Position paper is available now on our website. Please read it, share it, and tell us what you think. Thank you again all for taking part.